Okay, so we've talked about mixtures. Now we're going to be talking about solutions, which are actually types of mixtures. So if you recall with the mixtures, we talked about heterogeneous and homogeneous mixtures. So a solution is just another name for a homogeneous mixture. It looks the same all throughout. It's uniform. So just like any other mixtures, it has two or more substances that are mixed together, but it's distributed evenly, so it looks like one single substance. Again, hence the homogeneous, it looks the same throughout. So it was just another name for that. One thing about solutions is that we start talking about different terms like dissolving and solute and solvent. So the process in which the particles of the substance they separate and they spread out evenly throughout the mixture, that's called dissolving. So that's what's happening when you dissolve things. If you dissolve salt and sugar, or salt and water, or sugar and water, basically those molecules are just separating apart and they're spreading evenly throughout that mixture. So then it looks completely uniform. When we're talking about these solutions, the solute is the substance that is dissolved. So a lot of times it's a solid, but not always. And then the solvent is the substance in which the solute is dissolved in. So if you have salt water as a solution, salt is the solute and water is the solvent. Um, Obviously, in order for it to dissolve, the solute must be soluble. So soluble means that it's able to dissolve in whatever that solvent is. So salt is soluble in water because it's able to dissolve. Now, obviously, not everything is soluble in other liquids. Sand is not soluble in water. Sand just sinks to the bottom. So it just depends on what compounds you're looking at. Some examples of solutions. We have different types, and it's not always just solids dissolving in liquids. There's different kinds with our different states of matter. So, one is a gas in gas solution. Dry air is a gas in gas solution. We have so many different types of gases inside of our atmosphere. We've got mainly nitrogen, if you remember that from Earth Science last year. Mainly nitrogen, we've got oxygen, we've got carbon dioxide. There's lots of different gases and gas molecules that are evenly spreading and evenly mixing throughout. There's not one place where there's a lot more nitrogen and then all of a sudden you get to hit a chunk of oxygen. It's all spreading throughout. That's why it's a solution, but it's a gas in gas solution. Soda is a gas in liquid solution because you've got that carbonation is evenly spread out throughout the soda, the carbon dioxide that they put in there. So that is a gas in liquid solution. Antifreeze is an example of a liquid in liquid solution. I'm not completely sure what two liquids are in there, but I do know that it's made by dissolving one liquid and then the next. A solid in liquid would be something like salt water or sugar water, which is definitely our most common type that people tend to think about when you think of solutions. And then the last one is a solid in solid solution. So things like brass or steel, they're just different metals that are combined together. So they're melted together and they're spread evenly throughout to create this new compound, to create this new solution. So there are lots of different mixtures and solutions here depending on the state of matter. One thing about a mixture or a solution is that particles in the solutions are so small that they never settle out. So that means that they're going to stay mixed throughout. So unless you put way too much salt in a cup of water, you're not going to see that salt ever again. And if it is poured into the water and mixes throughout, you can't see that salt anymore. And it's not going to just over time settle to the bottom like it would if you put sand in the water. It's going to stay throughout. So you can't just remove it by filtering. You can't run it through a filter, run it through a strainer, and get those whatever it is that you dissolved out. Another thing about its solution is it doesn't scatter light. And what that means is if you were to take a flashlight to a clear glass that had that solution in it, the light would just go straight through. It would not bounce off any particles because they're mixed so uniformly throughout. There's not one place that's going to reflect light more than the other. So that's what that means when it says that particles don't scatter light.